Okay, so yesterday we did adding rational expressions. Today we're going to do subtracting rational expressions. And you may need this video for problems for the previous day. First thing that we're going to do is just another pre-example. First thing that I like to do with the subtraction problems is actually go ahead and make it an addition problem. So what I'm going to do is change this to a positive. But whenever I do that, I need to distribute the negative to my other terms. So this is just 4 plus negative 6. Okay, and now what I need to do is this one has a 5, this one has a 7, so that means this one needs a 7 and this one needs a 5. Again, multiply by the top and the bottom. Okay, 7 times 4 is going to be 28. 7 times 5 is 35. Negative 6 times 5 is negative 30. And 7 times 5 is 35. Now we're just going to add across step and leave our common denominator. 28 plus negative 30 is going to be negative 2. And since this does not reduce or simplify, this is our final answer. Okay, so we're going to be doing the same thing throughout today. We're just going to distribute the negative, and then we're going to treat it like an addition problem. So, example number 1. Let's see if I can keep my example straight today. First thing that I'm going to do is change this to a plus, and then make those a negative, or change the sign. Because sometimes it's already a negative, so then you got to change it. But okay, both of these have an x, so I don't need to multiply either by x. But this one has a 9, and this one has a 3. Now, before I multiply this one by 9 and this one by 3, what I'm going to do instead is I'm going to rewrite this as 3 times 3. Okay, so 1 over 3 times x, and then plus negative 8 over 3x. Okay, now you can see that this one only needs 1 3 on the top and the bottom, and this one actually does not need anything. So I'm going to multiply this top and bottom by 3. And that's all that we have to do for this one to get common denominators. So we're going to have 1 over, that is not a z, that's an equals, 3 times 3, which is 9x, and then plus negative 8 times 3 is negative 24. And then this is going to be 9x. And now we can just add across top, leave the common denominator. Okay, 1 minus 24 is going to be negative 23. And since these do not reduce, this is your final answer. Okay, let's move on to example number 2. All right, notice in this one, I already have a common denominator, so I'm not going to need to multiply each by anything. But what I am going to go ahead and do is change this from a subtraction problem to an addition problem. Okay, so I'm going to change this to a plus, make this negative 4x plus negative 3, or you can just make this minus 3, which is what I'm going to do. Okay, you have to distribute the negative to everything. All right, so if this was 4x minus 3, then it would be negative 4x plus 3. Okay, just going to change the sign on there. So now I'm going to rewrite this with everything on the top and the common denominator on the bottom. 3x plus 6 plus negative 4x, which is the same as minus 4x. So I'm going to write minus 4x, and then minus 3. This is all over our common denominator of 4x to the third. 3x minus 4x is just negative 1x. 6 minus 3 is positive 3, so plus 3. And this is all divided by 4x to the third. Okay. Since this and this do not have a common factor, then this is our final answer. All right, example number 3. And I did spill a little bit of coffee on this, but I didn't feel like regretting it, so hopefully you guys don't mind. Again, the first thing I'm going to do is change this to an addition problem, and I'm going to make this a negative. So I'm really just distributing that negative to the numerator. All right. They both have x's, but this one has 2 x's and this one only has 1. So this one is going to need 1x to look like the other. 7 times x is just 7x. And then plus negative 8, which is the same as just minus 8. And then this is going to be all over our common denominator of 9x squared. I did skip a step here. 7x over 9x squared plus negative 8 over 9x squared. If you guys needed that step, there it is. If not, this is your final answer. And this cannot reduce, so that's what you're left with. All right, example number 4. This one has a 3 on the bottom, and that one has a 4. But the first thing I'm going to do is change this to an addition problem and make that a -9. The reason I do this is mainly for problems like number 3, where you actually had to distribute the negative, because a lot of people would write minus 4x plus 3. That is not correct. You need to distribute to everything. So that's why I go ahead and distribute a negative at the beginning. All right, this one needs a 3. This one needs a 4. 2 times 4 is 8, so this is going to be 8x. 4 times 3 is 12. And then negative 9 times 3 is negative 27. 4 times 3 is 12. 8x and negative 27 cannot combine, but I am going to write them all in the same line. All divided by your common denominator of 12. This one cannot reduce either. Okay, so let's go ahead and look at some steps. If this helps you, then good. If not, then you can just skip the rest of this, but this is a quick little reference if you get lost. If you have a common denominator, you go ahead and distribute the negative to the numerator. Notice I put distribute because you might have more than one term. Now it's an addition problem, so you can just treat it exactly like we did yesterday. Same thing. If you don't have a common denominator, still distribute the negative first, then multiply each one by what it is missing. Okay, and now you have common denominators, so now you can just treat it like an addition problem. Okay, I hope you guys enjoyed this video. Please let me know if you have any questions. As always, have a wonderful day. Bye.